Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Farah Alia binti Mokhtar. Today, I will talk about the symmetry elements and point group for octahedron shape. This is the octahedron shape from the origami. I am sorry it is ugly because I don't clever at making the origami and I try my best to make this. This is the octahedron shape in origami. In octahedron, there have three types of rotation by 3/600 degree. There are three C4 axes because an octahedron has 6 vertices, which are all symmetry equivalent. We can see that there are also C2 axes where the C4 axes run. This is because rotating 2 times around 90 degree is the same as rotating around 180 degree. So we have to consider the operations C41, C42, C43 and C44. C44 is the same as identity, which is A, so it is not unique. In addition, a C42 is identical to a C21 and thus C42 is also not unique and can be expressed by the simpler operation, which is C21. This will leave the C41 and the C41 and the C43 as the only unique symmetry operations. Because we have 3 C4 axes, there are 2 times 3 that will be equals to 6, and that for the C4 operation, in detail there are 3 C41 and 3 C43 operations. In addition, there are the 3 C21 operations belonging the 3 C2 axes. Now, there are 4 C3 axes. An octahedron has overall 8 triangular faces and each C3 axis goes through 2 opposite faces. So there are 8/2, which is 4 for the C3 axis. Each C3 axis has the C31 and the C32 as unique symmetry operations. The C33 is the same as the identity, which is E. So overall, we have 4 times 2, which is 8 operations. Next, we have C2 axis that superimpose the C4 axis. An octahedron has 12 edges, and because each C2 passes through 2 edges, there must be 12 by 2, which is 6 for the C2 axis. Now, let's move to the next one, which is reflection. There are horizontal mirror planes that stand perpendicular to the C4 principal axis. You can see that a single mirror plane contains 4 edges for the octahedron. Because there are 12 edges, so there will be 3 horizontal mirror planes. There is 1 mirror plane per principal C4 axis. Then, there are 3 horizontal reflection operations because there is always 1 reflection operation per mirror plane. Next is vertical way. You can see that the contrast to the horizontal mirror planes, it does not contain any edges. Rather, it cuts through 2 opposite edges. You can see that this plane contains a C4 axis, but it does not stand perpendicular to the other 2 C4 axes. Therefore, it has only the properties of a vertical mirror plane. You can see, however, that the mirror plane bisects the angle between the 2 C2 axes, which is also depicted. This makes the vertical mirror planes dihedral mirror planes, which is the sigma D. How many of them do we have? As previously mentioned, each mirror plane cuts through 2 opposite edges. There are 12 edges in an octahedron, and thus there are 6 dihedral mirror planes. Next thing is improper rotation. The improper axis passes through the centers of 2 opposite triangular faces. One can see that rotation about 60 degree alone does not make the octahedron superimpose. The reflection at a plane perpendicular to the improper axis is required to achieve superposition. Overall, the rotation reflection swaps up the position of the 2 opposite triangular faces. Since each axis passes through 2 faces and an octahedron has 8 faces, there must be 4, which is for the S4 axis. The octahedron also has S4 improper axis. It goes through 2 opposite corners of the octahedron. The S4 improper axis seemingly does the same as the C4 axis that goes through the same two opposite vertices, but actually does not. While rotating around 90 degrees already makes the octahedron superimpose with its original form, executing the reflection operation after the rotation swaps up the position of the two vertices, and generally all points of the octahedron and below the plane respectively. Overall, the S4 moves the point within the object differently compared to the C4, which makes it an additional unique symmetry element. There are overall 3 S4 improper axes because the octahedron has 6 vertices and one S4 passes through 2 vertices. And lastly, octahedron has inversion. Each point in the octahedron can be moved through the inversion center to the other side, and the produced octahedron will superimpose the original one.